students. In today's class, we'll be discussing about recursion function. Already you had studied about the function pointer concept, how parameter is passed among the functions. So in today's class, we'll be discussing a different kind of function used to develop algorithm strategies which are of the form divide and conquer. Now, in the earlier class, as all of you know, we have studied about the pointer, how pointer is being used in C, what is multiple indirection, how multiple indirection, how reference variable and pointer from each. Now, what is a recursion? It is a process by which a function calls itself directly, like for example, x, or cyclically in a chain like x calls y and y calls. It is used for repetitive computation in which each action stated in terms of a previous result. For example, if you want to compute factorial of n, for that you require previous result, that is factorial n minus 1. So thus the problem has been resolved using n cross factorial of n minus 1 for computing factorial of n. For a problem to be written in recursive form, two conditions are to be set. It should be possible to express the problem in recursion form. The problem statement must include a stopping condition. Example, in the problem that we have taken here, this factorial of n, while computing factorial of n, the stopping condition is when n equal to 0. So the problem here, the problem situation is very trivial. The output will be 1. Otherwise, it will be n into factorial of getting a solution using the previous. Now, recursive functions are used to reduce a complex problem to a simpler solved problem. The simpler to solve problem is known as the base case, which is trivial. Recursive call stops when the base case is fixed. Recursion function must always include a test to determine if another recursive call should be made or if the recursion should stop with this call. Different value is passed to the function each time it is called. Of course, in smaller in size, the parameter will be. Eventually, the parameter reaches the value in the test and the recursion. Here, you have considered three problems. One is factorial, another is many numbers, and the Fibonacci. Now, in case of factorial, here the test, here the base condition is, as you have seen, when n equal to 0. So trivial and it will output will be 1, and otherwise factorial n will be n factorial of n minus 1 if n is problem size is greater than 0. In case of GCD of m, if both the values are same m and m, both n is also m, then m. Otherwise, if m is greater than n, then GCD of mn will be GCD of m remainder n, comma n, or otherwise if m is less than n, then GCD of mn will be GCD of n, comma n. So everywhere the test condition is always there. In case of Fibonacci series, here the trivial case is the two trivial problem size. One is when n equal to 0, one is when n equal to 1. If n is equal to 0, it is 1. It should be 0, and when n equal to 1, it is 1. So based on where from you start. If you start from 0, 1, then Fibonacci 0 will be 0, or otherwise start from 1, then Fibonacci 0 will be considered. Here, two base conditions are there, or otherwise, as you know, for Fibonacci of n, it has to consider previous two value, Fibonacci of n minus 1 or Fibonacci of n minus 2. So one problem, demonstrated here how to write recursion function, like in case of factorial n itself, the function name I am giving as fact, FSCT, return type is int, and the parameter that we are passing is int. These are type again and m. So I'm taking a variable f, because here I should be, f is a variable. As you have seen, first I'm checking whether n is equal to 1, because it's the base condition. If n is equal to 1, then f will be 1. Otherwise, it will call the function itself, but for a smaller value. Therefore, if n is not equal to 1, then again the function is called with respect to n cross factorial of m. And accordingly, it will be, the function will be called again and again as long as n is not equal to. We have taken our example for this one. Suppose we are going to compute factorial of 4. So therefore, n will be 4 here. So for computing factorial of 4, as you have seen, we are computing 4 into factorial of 3 and into factorial of n minus 1. So therefore, n minus 1 will be here 3. Now for computing factorial 3, again you require factorial 2. Similarly, for factorial 2, again you require 2 into factorial 1, so factorial 1. Again for factorial 1, you require 1 into factorial 0. Now if I consider factorial 0 is 1, then it will be the same value will be returned in reverse order. Then once you get the factorial 0 equal to 1, that value will be used for computing factorial 1, that is 1 into 1. Then again that value will be used for computing factorial 2. So therefore you will get 2 into 1, which is 2. Again the same value will be used for computing factorial 3. Therefore 3 into 2 equal to 6. And that value will be used for computing eventually 4, which is 6, that is 4. The same you can understand through this diagram also. As you have seen, for factorial 4, first it will check whether 4 equal to 1. It is not 1, so it will go to the else part and it will give you 4 into factorial 3. Again here 3 is not equal to 1, again it will go to the else part, so 3 into factorial 2. Again 2 is not equal to 1, so it will go to the else part, so 2 into factorial 1. Again it will go factor effect 1 equal to 1 now this time, so it will return 1. Or otherwise, if you do not, if you want to go down to n equal to 0, then again it will go to the return, else but return 1 into factorial. Accordingly, it will get the value from the lower level, and that value will be used in the upper level for computing the higher level solution, and in the subsequently you will get the factorial as has been demonstrated in the. Similarly, for Fibonacci, as you have seen, if I consider factor Fibonacci 0 equal to 0 and 1, then in that case, we are considering the series starting from 0, 1, whereas Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 1. As you have seen here, now for computing Fibonacci of 4, so therefore you require Fibonacci 3 and 2. Again, for Fibonacci 3, you need to go for Fibonacci 2 and Fibonacci 1. Similarly, for Fibonacci 2, also you need to go for Fibonacci 1 and Fibonacci 0. And for another one, Fibonacci 2, again Fibonacci 0. And so once it gets Fibonacci 1, then it will return 1. Fibonacci 0, it will return 0. And subsequently, you will get at each function call, you will get value in down upward direction, and you will be able to compute Fibonacci 4. Therefore, as you have seen here, 9 times your function will be called. There are some important points which you need to be careful about while writing a recursion function. Every recursion program can also be written without recursion. Now, always you remember, recursion is used for programming convenience, not for performance enhancement. You have seen here, in case of recursion function, for programmer, although because the number of statement gets drastically reduced, so from programmer's point of view, it is convenient. But so far the space is concerned, as you have seen, for every recursion call, one stack gets created. So therefore, so for space is concerned, it is not so efficient. Sometimes if the function being computed has a nice recurrence form, then recursive code may be readable. And there is another thing that all of you are supposed to know. What is the difference between recursion and iteration? In case both are used for repeated task. In case of iteration, it is through explicit loop, but in case of recursion, it is repeated function calls within its termination. In case of iteration, loop when the loop condition fails. In case of recursion, when the base condition is both can have infinite loops, but the balance, the choice between performance and good software engineering. For performance, you should go for iteration because in case of recursion, base requirement is high, but recursion is a good engineering practice. So, as a summary, in today's class, you have studied about the recursion function and you have got to know through demonstration of some example how recursion function can be created by dividing the problem into programs, the smaller problems. So for the references are concerned, these are the references that is being used. If you have any contact, you can always contact me in the address given. Right? Thank you, students.